So we're going to go ahead and we're going to start with solving not right triangles, but oblique, or just solving any triangle. That means today we're going to use both the law of sines and law of cosines. Once again, make sure you have replaced your notes with the new ones. Your old ones were incorrect. And once again, you'll know as soon as we start because you won't have boxes off to the side. All right, so real quick rehash. Law of sines, that's sine of A over side A equals sine of B over side B and sine of C over side C. Law of cosines. This. People are very loud today. As a reminder, don't worry about the A's, B's, and C's because the triangles you have don't necessarily have A's, B's, and C's. Basically, what you want to recognize is the ones I'm boxing in right here. One of those two will be your unknown. Either you're missing a side, and so you kind of have x squared here, or you're missing an angle, and we'd put an x right there. You must be missing one of those, but you need to have all of the rest. So those are your key ones to keep track of. Now, when do you use the law of sines? Can someone raise your hand and tell me when do you know to use the law of sines? Oliver.
When you have an angle on the side across from it.
When you know an angle and the side across from it. So when you know an angle and the side across. And not to ask a trick question, but when do you use the law of cosines then?
When you don't know the angle.
When you don't know an angle or a side across from it. So in other words, when you can't use the law of sines. We always check to see if we can use the law of sines first, because which one of those formulas is easier? Sines. The sines is the easier one to really deal with, so we always look to see if we can use that. So law of cosines, we use that when we can't use the law of sines. When we can't use the law of cosines. All right, so we always check to see if we can use the law of sines first. So let's real quick look at what problems like this are going to look like. Example 1 says use the law of sines and law of cosines to solve each triangle. So we're going to use the law of sines and the law of cosines to solve each triangle. Do I have an x or a y I'm solving for?
Yeah.
No. It's just telling you you need to find all of the missing pieces. You need to find all of the missing pieces. So that means I need to find a missing side. I need to find a missing angle. And that's really it. So our question is going to be, can I use the law of sines right now? No. I can't use the law of sines because, and let's go ahead and circle that. I know the angle, I just don't know the side across from it. So let's put an x there. Let's say that's a good place to start because I do have an angle that leads to a side and means I can use the law of cosines. So this right here says, oh, use the law of cosines, dude. I have an angle, I have a missing side across from it. Let's use the law of cosines. Now the law of cosines, now be careful because don't write too big. Basically, we need to have room to do the law of sines and the law of cosines. So maybe in your head, just have kind of a divide right here that you don't go past that. Okay, so law of cosine says missing side squared equals my other two sides squared and added. So that's 10 squared plus 7 squared minus 2 times those two sides again. So that'd be 10 times 7 times the cosine of 132 degrees. I guess I didn't do a good job keeping off to the side. Here's the one good thing about the law of cosines, though. When you're finding a missing side, we just plug all of that information into our calculator. So I will now type in 10 squared plus 7 squared minus 2 times 10 times 7 times cosine of 132. Don't shout out an answer. Just I would like everyone to have a chance to write it down and plug it in. So we are currently plugging in 10 squared plus 7 squared minus 2 times 10 times 7 times the cosine of 132. Can someone get me this result? Don't give me the total result. Don't take the square root, but what do I get out if I plug all that in my calculator to the nearest tenth? Yeah.
242.7.
242.7. Can I get a second on 242.7? Okay, sounds good. But that is not my missing side. I now have x squared equals that. So we have to remind ourselves, oh, that means I have to take the square root of both sides. And so I'm going to have x is about, what's the square root of 242.7? Can someone new? Yeah. 15.6. Do we concur on 15.6? Yes. Okay, 15.6 is my missing side. Now we should go over here and go, oh, that means EF equals 15.6. So I'll come over here and I'll fill in that 15.6. There's a whole lot of chatter. Do people have questions? Okay, did I solve this entire triangle? No, I did not. However, look at what I now have. I can now fill in x. What was that? You sure? Okay.
So now you can do the sine, right?
Now I can do the law of sines.
So you can just do 132.
Because now I have that 132 and that 15.6. Awesome job recognizing that. So now I can go back and go, can I use the law of sines now? Yeah, I can go, 132. I now know that side across from it. So I can now go, well, this is going to be my key. I'm going to say the sine of 132 over that 15.6. Let's put a 15.6 is going to help me find that missing angle. Which one did I find? I ended up finding E. It doesn't matter. You'll get the same answer if you find E or if you find F. Real quick, what is the side opposite angle E? Yeah. 10. 10 is. So to finish off this equation, we'll go the sine of, well, I don't know this value. That's why I put a y there. I'd rather put like a variable there so I don't have to keep putting angle E over and over and over. So I'll go the sine of y over the side opposite it, which is 10. Now we need to solve for y. That means I need to multiply both sides by this 10. Can we do cross multiplication? Yeah. Sure. Do you want to see a nice shortcut to this one? Yeah. What happens if I multiply this side by 10? What if I just multiply this by 10? What happens to this 10 here? It cancels out, which would just move the 10 over to this side. You don't always have to cross multiply. If you just want to get rid of the denominator, this obviously doesn't work if this was an x in here, but if you have a number here, you can always just multiply by that number, giving you sine of y equals 10 times sine of 132 over 15.6. How do I move sine to the other side? I use the sine inverse. So I'll take the sine inverse of both sides, giving me y equals the sine inverse of, now there's no reason to rewrite this. I'm just going to say all of that crap. I'm going to throw all that crap in my calculator. I'm going to type sine inverse. I'm going to do 10 times sine of 132 divided by 15.6. Let's all take a second and plug that in and make sure we're doing it correctly. All right, can I get someone new? Someone that hasn't given me an answer yet? Tell me what you got to the nearest 10th. Remember, you could be wrong. I'm going to say it's 14.2 degrees. That's wrong. Matt?
28.5.
28.5. Did anyone else get 28.5?
Oh,
28.4, we're okay with 28.4? 28.4 degrees. All right, guys, that gets me, what, angle E? Should I use the law of sines to get angle F then?
No.
Why not?
You just subtract from 180.
Oh my God. Once I know two angles, we should just go 180 minus those two angles. So to get to F should not be a big leap. We should just go 180 minus that 132 minus that 28.4. Shout it out. What's our angle F?
19.6.
19.6 degrees. The only reason I'd use the law of sines or cosines to find that missing angle is if I have like a ton of time and I'm like, I just want to check to make sure I did all that work correct. Because you should, if you use the law of sines, say I put y over that 7. If I put a 7 in here instead of that 10, I should get out that 19.6. Questions on that? All right, so what I want to point out here is when I say solve a triangle, I'm asking you to do the law of sines or cosines, but you have to do it twice. So in this case, I had to use the law of cosines, and then I had to use the law of sines. So you have to do two things. That's why we got such big boxes. Okay, let's do our next one. Our first check is, can I use the law of sines? Yes. And in fact, what are you saying, Will?
You have a side across the angle.
I have a side across from the angle. In fact, before I do the law of sines, what might my first step actually be? Yeah. Find the other angle. I should find angle N, because if I'm given two angles, let's go ahead and find that third angle right off the bat. So that means I'm going to take 180, I'm going to subtract 129, I'm going to subtract 21, and that should leave me with 30? Are we good with 30 degrees? So that angle N would be 30 degrees. All right, that means the only thing I'm missing is those two sides. Let's put x's and y's on those two sides so I know that I'm looking for those. X and y. All right, our key is already circled, so I should be using that sine of 129 over 5. And that's going to equal 21 degrees. Is that across from y or x in my example? Ooh. Is the 21 degrees across from the x or the y? Y. It's across from the y. So when I do the sine of 21, it'll be across from side y. I'm going to make a break right here, and I'm going to go ahead and do the other one as well. I'm just going to start the other one. The other one would be sine of 129 over 5 equals, what's across from the 30 degrees on mine? X. So we're going to go sine of 30 over that x. And now we'll do our cross multiplications on both of these. We can kind of do these at the same time. So on this one, my cross multiplication would look like this. I'd have y times sine of 129 equals 5 times sine of 21 degrees. I'm going to slide on to the other one and show you that, hey, these are basically the same thing, except with slightly different numbers. I'll have x times sine of 129 equals 5 times sine of 30 degrees. What's the only thing different between this one and this one?
The 30 numbers.
The 30 and the 21. Those are the only things that should be different are the 30 and the 21. Note this 30 and this 21 are the only things that are different. Now, I should divide by sine of 129, giving myself y equals 5 times sine of 21 degrees, all over sine of 129 degrees. And for the other one, I'll have x equals 5 times sine of 30 degrees, all over sine of 129 degrees. Now, I'm pointing this out to you that this 21 and this 30 are the only things different in there. Because if you have one of those nice graphing calculators or a scientific calculator that saves the formula, here's what I would do. So if I had a graphing formula, I would just type in 5 times sine of 21 divided by sine of 129 degrees, get that answer, and then I would just slide up and replace that 21 with the 30. Depending on what calculators you have, that can be a very quick and easy thing. But let's take a second and plug in both of these. Let's plug in our 5 times sine of 21 divided by sine of 129. And let's plug in our 5 times sine of 30 divided by sine of 129 and see what we get out. So I'll give you guys all a second to plug that in. You should all be plugging these in. I don't care how super confident you are using your calculator. Don't lose points on this quiz on Friday because you don't know how to plug something in. So if you are getting all of these incorrect on your calculator, now's a great time to say, Mr. Pabian, I haven't got one of these correct. Maybe I should learn how to, maybe you can show me how to use it, or maybe your calculator's messed up. There was one year where someone's calculator was completely messed up, and they straight up gave wrong answers. All right, did anyone find y yet? Ty? 2.3. Are we okay with 2.3?
Yeah.
All right, cool. And then did someone else get x? Yeah. 3.2. Is everyone okay with 3.2?
Yes.
Okay. Now, I'm going to go ahead and put these in. Now, look at my y is my mn, so this would be my 2.3. And my x stood for my ml or lm, so this is, I'll put my 3.2. Hey, it's a good idea to check to make sure your answers make sense. See how this length is 5? Does 3 and 2 generally fall in line with a short length of 5? Yeah. If I had a 5 here and all of a sudden these came out to like 1,333, you probably made a mistake. Doesn't mean you're guaranteed, but always look at things in the realm of possibilities. Do your answers make sense with that triangle? In fact, we can look back here. I mean, this makes sense. 28.4, 19.6, 15.6 makes sense in the context of 7, 10, and 132. All right, I'm going to skip this one for just a second. I want to get to example 4 for sure. Example 4. Can we use the law of sines? No, I can't use the law of sines. Can someone new that hasn't told me yet, why can't I use the law of sines on this one? Maybe someone hasn't. Yeah. What was that? There's no angle, so there's no way we could have an angle and a side across from it. There is no angles. Now, we have to find missing angles, right? Does it matter which one I find first? Not technically, but I'm going to put a caveat onto this. If you have an example that we have 3 missing angles, find the biggest one first. We don't have enough time to go through why we're finding the biggest one first. Basically, there are 2 possible triangles because of this, because of how it's set up. There's one where that angle's acute, and there's one where it's obtuse. So, turns out, and once again, this is a whole day's worth of lesson that we're skipping, basically. It's a really complex thing where we have to do like heights and altitudes and stuff. We're just not going to get into it. If I find C or A first, it can actually mess up our triangle. We can actually get the wrong information because it thinks it's a different triangle. If you find the big angle first, you don't have to worry about that. Do you guys ultimately have to worry about that? On your homework you do, on the quiz you don't, because I'm going to pick an acute one. But I do want to preface the fact that if you have all your angles are missing, find your obtuse one first, or find the one that looks the biggest. And the biggest one must be across from 29. So I'm going to go ahead and I'm going to find this one first. Once again, this doesn't have to be something that you have to memorize for the quiz, but it's a good thing to know that when you're using law of cosines to find an angle, find the big one first. So we're going to go ahead and we're going to use that 29 to get to that x, and we'll use the law of cosines. Now, as a reminder, make sure you give yourself a little bit of space over here so that you can do your next thing. So you know you have to do at least 2 steps. All right, so in this case, we have a known side, so we're going to have 29 squared. 29 squared is going to equal the 2 other sides, so that would be 24 squared plus 14 squared. It will be minus, I should really give myself a little bit more room. Slide that over. 14 squared minus 2, and we do the 2 sides again, so that would be 24
What do you do cosine of x?
times 14, and we'll do cosine of x. Perfect. So we'll do cosine of x. Now, this is the hardest way to use the law of cosines because I can't throw that whole thing in my calculator. I have to work it bit by bit. So I have to simplify that 29 squared. I have to simplify these 2 things. I have to do that multiplication here. So let's help me out real quick. 29 squared, what does that equal? 341. Did I do that right? 841. That makes a lot more sense. All right, now what happens when I combine 24 squared plus 14 squared? What do I get out? So 24 squared plus 772 minus, and now I have 2 times 24 times 14. What does that come out to be? 672. Did I hear that right? And then we have cosine of x. Now, reminder, do not do this subtraction. You cannot. You have to move this over before, because this is held on by multiplication. This is held on by subtraction. You need to move this over before you do that work. So we do have to subtract both sides by 772. So we'll divide by 772. Let me make sure all my numbers are correct so far. We're good. What is that? 69 equals negative 672 times cosine of x. How do I move that negative 672 to the other side? Should I use addition or do I use I use division because it's actually attached by that multiplication. So I'm going to divide both sides by a negative 672. Realize that in your calculator you have a negative button for most of us. So now I have 69 divided by negative 672 equals cosine of x. We should realize at this stage we need to take the cosine inverse of both sides. Take that cosine of inverse of both sides. So I'm going to have cosine inverse of 69 divided by negative 672 is going to equal x. Will, what did you get?
95.9.
95.9. Did anyone else get 95.9? X equals 95.9. And let's go ahead and say, okay, that's angle B. Angle B is 95.9. Now, I will tell you, you could use the law of cosines again to find another angle. Well, let's go ahead and point out that angle. I picked A. You could have picked C, doesn't matter at this stage. I picked A to find next. Now, we could use law of cosines, but could I use law of sines to find Y? Why? Why can I now use the law of sines when I couldn't before? Joseph?
Because now you have an angle across from the side.
Oh, because now I have an angle across from that side because that x right now is, we now know that value is 95.9. So that's my now key to use the law of sines. So our law of sines will be, take the sine of 95.9, divide that by the side opposite, which is 29, and that's going to help me find that angle y. We'll have sine of y divided by 14. Now, we could use cross multiplication. In fact, this time I will. I'll use cross multiplication. I showed you a shortcut on the other one. I'll do the long way this time, depending on where you are or what you're comfortable with. So we have 14 times the sine of 95.9 equals 29 times the sine of y. Divide both sides by 29, and you'll have 14 sine of 95.9 divided by 29 equals sine of y. Everyone, how do I move y, sine to the other side? How do I take sine and move it to the other side? How do I take sine and move it to the other side? How do I take sine and move it to the other side? Sine to the other side? Cosine to the other side? Tangent to the other side? Sine to the other side? So we should know, just take the sine inverse of the other side. So I should have x equals sine inverse of 14 sine of 95.9 divided by 29. I think several of us are ahead of me. What did we get out for that one? Did anyone get that already, Matt? 28.7. Can anyone second 28.7? We're good with 28.7? All right, so we have 28.7 for, I had angle A. Oh, I don't have to use the law of sines to get the last one? Oh, because triangle, they all equal 180. So we just do 180 minus 28.7 minus 95.9. What is my angle C? 55.4. I hope someone else got that too. All right, do we have questions on these? So these are kind of what's going to show up on that quiz on Friday. In fact, I will never tell you to use the law of sine or cosine. You have to decide on every single problem. Some of the problems are solve the entire triangle. Some might give you a value, like I say, find x. But you got to figure out how to do that. Now, we did skip this one. However, can someone tell me how to start this one? Joseph? We'd find that last angle. Did anyone find that last angle? Maybe you got ahead of me and you actually found that angle. 38 degrees. And then would we use the law of sines or cosines? We would use the law of sines. And we could find that missing sides that way. I will put the information down that I got from this one if you'd like to practice it. But I'd rather just go ahead and get started because I don't think we have a ton of time. We've got like 10 minutes. I came out with QR equals 8.6. I have SR is 9.6. And I came up with angle R turns out it's 38 degrees. You got those? Oh. All right, guys. Any questions on anything we covered? Actually, we only got like a minute.